All right, welcome to lesson 3 for chapter 9. We are still talking about issues with fossil fuels, but we are focusing on oil and natural gas because those two form together. So learning goal is that you'll be able to explain the impacts that extracting and using oil and natural gas has on the environment. So the energy content of oil is more concentrated than coal. So even though coal is the most abundant, we get more energy out of oil. It also burns cleaner and is easily transported through pipelines. So if we are mining coal over here, we can build this pipeline, which in itself is a disruption to the environment, but is easier to transport than having to truck things everywhere. These qualities make it ideal for automobile use. So again, the gas that you're putting into your car, that is an oil component that comes from oil. And locating and extracting oil causes less environmental damage than coal mining. So we talked about coal mining. You can either do strip mining where you're stripping off the surface, or you are doing underground mining, which is dangerous and also has some consequences. And once a source of oil has been located, it must be extracted and transported to the surface. So there's 3 different recovery methods. First, or 3 kind of steps. So the primary recovery method, if water or gas pressure associated with the oil is great enough, the oil is forced to the surface when a well is drilled. So there's kind of already pressure coming from under the oil. And remember, there's like a cap of rock over the top. So as soon as the drill goes through that cap of rock, the pressure releases and the oil goes up the well. If water and gas pressure is low, oil is pumped to the surface. So we're adding some energy there. And then 5 to 30% of the oil is extracted with this method, depending on the viscosity and the geological characteristics. So how thick the oil is, how far down it is, how much pressure there was. In secondary recovery, water or gas is pumped into a well to drive the oil out of the pores of the rock. Because remember, we have that impermeable rock layer that we're drilling through. That's this right here. And then this kind of space right here that we have the oil and water going through, it's not just an open kind of pipe, it's just, or like tunnel, it is rocks with space in between that the oil is filling up. And so with secondary recovery, we push water and /CO2 down into that space to push more of that oil out. This allows up to 40% of the oil to be extracted, which is a little bit more than we saw in primary. And then last but not least is the tertiary recovery. So steam is pumped into a well to lower the viscosity of the oil. So we heat up the oil, and if you've ever cooked with even just like cooking oil, when you heat up oil, it gets a lower viscosity, which means it's more like watery. It's easier to get out. An aggressive pumping of gas or chemicals can be pumped into a well. So it might not just be steam, there may be chemicals going in as well. These methods are expensive and only used with high oil prices. Remember the difference between resource and reserve. Resource is how much we have, reserve is what we can actually extract. So depending on how much money we can get for this oil, this may make sense and it may not. If it makes sense and it's profitable to pump the oil this way, then that would be a part of the reserve. If we know the oil is there, but it's not profitable to recover it this way, then it would not be considered a part of the reserve. So there's also offshore drilling where it's just kind of like middle of the ocean or offshore. And then this is another show of secondary recovery. So here's our main oil well right here. And then we have 2 other wells that we're injecting water into to push that oil out. All right, and when we are using oil, first we have to process it. So as it comes from the ground, oil is not in a form suitable for use and it has to be refined. And multiple products can be produced from a single barrel of crude oil. Obviously, one issue with oil use is oil spills. So accidental spills actually only account for about 10% of oil pollution resulting from shipping. And the effects are still poorly understood. We see them and they seem really awful, but it's hard to understand how much they're really affecting. This is what an oil tanker looks like, so transporting oil through the ocean. And then this is how we transport oil terrestrially or on land. So for environmental issues, if we're looking at oil spills, it's estimated that worldwide only 10% of human-caused oil pollution comes from tanker accidents. The top 2 are actual natural seeps, 47%, and then consumption activities, us actually driving boats, driving cars. That releases 38% of the marine oil pollution. And then transmitting oil is about 12, and then ocean oil drilling is 3. And over time, we have increased technology, increased safety, increased protocol so that the oil spills coming from tankers have gone down over time pretty significantly. There was one big spill like 2018, 2019. All right, and then natural gas. Natural gas is formed with oil, and so the drilling operations to obtain natural gas are similar for oil. It's hard to transport, and in many places, it's still burned off at oil fields, but there's new transportation methods being developed. We can now liquefy, so any gas technically could become a liquid if we get it cool enough. For natural gas to become a liquid, it's a negative 126 Fahrenheit, which is pretty cold. But the public is concerned about the safety of those loading facilities, so they are located offshore. So it's really just offshore natural gas drilling that we can liquefy and transport because people don't want this happening near them. Natural gas is the least environmental damaging fossil fuel. That does not mean that it is perfect. That does not mean it is not damaging, but out of coal, oil, and natural gas is the cleanest. It releases less carbon dioxide than coal or oil, and it's commonly used to warm homes and in some appliances, stoves and dryers. So if you have a stove at home that is fire like that and it's not electric, that's natural gas. A lot of water heaters, especially the older ones, the pilot light it's natural gas. Furnaces, like what is warming the air coming out of the heaters in houses and buildings, mostly natural gas. So that is natural gas being burned in a home. So it has to burn cleaner than coal or oil because we're breathing that in. All right, that is the end of this lesson. Please let me know if you have any questions, and I will see you in the next one.